something that we need to do a lot in physics is to convert one vector at an angle into two vectors that are at right angles to each other, and that's called finding components. For instance, if we had a human cannonball, and this human cannonball was shot out of a cannon 30 degrees above the horizontal at a velocity of 40 meters per second, and that's pretty quick. That's getting up there. We need to find the horizontal velocity, because that'll help us find out how far along we need to put the catch net, and that's pretty important if you're a human cannonball. Otherwise it's bad for your health if you crash to the deck without the catch net. We also need to find the vertical velocity, because that will help us figure out the hang time. The faster you go up, the longer you spend in the air. So to do this, we start with I'm going to find the horizontal velocity first. Using year 11 trig, the cosine of an angle is equal to the adjacent over the hypotenuse, the angle in there. In this case, the cosine of 30 is equal to the adjacent, well, there's the angle, so this is the adjacent here, the horizontal velocity, divided by the hypotenuse, and the hypotenuse in this case is 40. The next step is a complicated one called swapping sides. So we do the horizontal velocity divided by 40 is equal to the cosine of 30. Now, what I want to do next is to multiply both sides by 40, because I want to undo the clutter that is around the horizontal velocity. So those two cancel, and I've done the same thing to both sides, so the equal sign still is fine. We get the horizontal velocity is equal to 40 times the cosine of 30. Well, the cosine of 30 is 0.866, but that's also equal to the square root of 3 divided by 2, and that's times 40. And we can do a little bit of number crunching here, or a bit of fraction work, and we can say, well, 2 goes into that 20 times. The horizontal velocity is equal to 20 times the square root of 3, and that's going to be equal to around about, let's have a go with the calculator, square root of 3 times 40, sorry, times 20, that's 34.64 meters per second that way across the ground. Now what I might do is just partition this off a little bit. Now let's do the same sort of process for the vertical velocity. Well, using fifth form trig, we can redraw this triangle here. That there is 30 degrees. This is the vertical velocity. This is the horizontal velocity. Horizontal velocity. And up here is the hypotenuse, which is 40 meters per second, which is the launch velocity from the human cannonball. Using the sine of an angle is equal to opposite over hypotenuse. In this case, sine of 30 degrees is equal to the vertical velocity divided by 40. And I'm going to do a next complicated step called swapping sides. Vertical velocity divided by 40 is equal to the sine of 30. I want to undo the clutter so I can get my vertical velocity all by itself. So multiply both sides by 40 to undo that divided by 40. Those two cancel. The vertical velocity is equal to 40 times the sine of 30. Well, the sine of 30 is a half. And vertical velocity is equal to 20 meters per second upwards, because it's a velocity. We need a direction as well. So we now know that this here is equal to 20 meters per second up, and we have now broken that single vector at an angle into two vectors that are at right angles to each other. And if we want to, we could add them back together again to using vector addition. But that works for force vectors. In this particular case, it also works for velocity vectors, and that's really useful for projectile motion.